No, go ahead.
Oh, go do the transcript thing too. And we can talk about this if you want. I mean, I was going to say we should at least pre-record a segment.
Yeah,
Um, but what you're talking about is very, very. Now, are you familiar with Sparkle?
I do know Sparkle. Yeah.
Wasn't that was out of Cambridge Semantics, right? Barry Zane went over there, and I want to say he was behind Sparkle, which was um, well, it was like an RDF query language, right?
It's part of the W3C standard for RDF. And that's continued. So if you look at RDF, that really came out of semantic web, um, and
Right,
this idea
right.
that you'd be able to tag the World Wide Web, which is which is a graph, like it's this interconnected data,
Hmm.
and be able to reason, share data, exchange data, understand what's out there, build taxonomies, ontologies. That's obviously developed quite a bit since then. And one of the things that has been going on for probably close to certainly more than a decade, maybe two, is to have databases that are based in RDF. So that's sort of like one graph model. Um,
Hmm.
and then the other graph model, which is the basis, or what was defined in the new ISO-GQL standard, is a property graph model. And
Hmm.
I sort of think of RDF as maybe like fifth normal form in the relational world. Everything gets normalized. And
Interesting.
so, whereas in the property graph world, it's built, conceived from the beginning for data in databases.
Okay.
So it's a different origin story. And so it ends up being maybe more like third normal form. So you have nodes, and those nodes can have a label, um, which is kind of like a person label, an employee label, et cetera. And then each node can have properties, and then you have relationships, which can have a direction and type, and those relationships can have properties. Whereas in RDF, you don't have relationship properties, and everything sort of gets normalized. So it ends up being like I have, if you visualize it, it's uh, in a property graph, it's the Philip node has hair color, eye color, date of birth, whatever. In RDF, it's like I have a relationship to my hair color, which is a different node, and I have a relationship to my, and
I
so
see.
on.
So it's closer basically.
It's
In
what
in
we find is users who have looked at both tend to find that while RDF is very like theoretically deep and elegant, it's
hmm
really hard for like the
it's
average developer to work with.
it's
And so,
impractical basically. It's not
y-
practical. Whereas a
yeah,
property graph, you're almost treating the properties more like first class citizens. Is that right?
yeah, you're treating you have properties kind of in the same way you do, columns in a database, in a
Hmm. So it's easier
table.
to do an analysis on find me all the people with red hair kind of thing. It would be faster. It would be a couple steps more in RDF to generate that report. But if it's a property graph, it's faster to be able to say, show me all the people with red hair. Is that
Yeah,
correct?
it's easier to the language and model are closer to your logical model.
Hmm.
So one thing that's kind of magical about working with um, property graphs and all, kind of all the Neo4j users and customers I've seen over the years is your conceptual, logical, physical model are almost identical. Like, and not to say that you don't do physical normalizations, as you scale data, just like you do in any other kind of database, but the way you would draw data on a whiteboard matches the way it lands into the database, um,
Hmm.
and is physically stored on disk and represented in memory and so on. Um, and you don't exactly have that with RDF. It's a more normalized view. So there's an impedance mismatch that's not
Hmm.
there. Um, and actually, one of the not the reason people think about when adopting property graphs. Usually, it's something like either I have connected data, I see my use case as a graph, I run into some performance problem, or I need the schema flexibility. But the I actually retrospectively, what people often realize once they've been down the journey for a few years, that the um, the fact that these conceptual, logical, physical model are so close improves communication inside of IT, so between developers and DBAs who normally have
Interesting.
these, domain view versus like your database view, which are very different.
Hmm.
So
Hmm.
a lot of friction that exists on projects and in organizations is that, and also between the technology people, so IT and the business, because they also speak different languages, like the language of, some normalized schema, which took 3 months to develop based on some whiteboarding exercise.
Right.
And so and then God forbid, you evolve this schema. Oh my God, like then you have a 1 hour migration window where you have to have back a plan to reverse it if it doesn't go well and so on. And with a graph model, at least with schema flexible implementations of a graph model, this is another, thing is different vendors have taken either like a fixed schema or a flexible schema approach. But with a flexible schema approach, you can just add data as it shows up in the real world. In the database, it looks the way it looks like in the real world. So then you can turn around and visualize the data, show it to a domain expert, and oftentimes people will jump out of their chairs and say, I've been working in biology for 20 years. I've never seen it, and just run and get their colleagues.
Wow. We should, I mean, this is very interesting stuff. We should, if you're interested, we should just hit the record button and like and do a show here on the standard, the fact that
Yeah.
it's just gotten through, and have you just kind of walk through some of the things you just did, explaining the difference. And I especially like to focus on flexible schema versus what was the other option you called
Yeah.
it? Fixed
You
schema.
could say fixed. Yeah.
Okay, because to your point, and this is the interesting thing about that dot, and granted they are a niche player, they're focused now on advanced persistent threats just because they think they're better than anyone else in that space. But I understand, and he talks a lot about analyzing categorical data.
Mhm.
So not just numerical functions, basically, but understanding concepts and being able to model them. And that's very interesting, especially for complex problem solving. Graph is very powerful because it is not, you're not forcing the square peg into a round hole with a graph. You're just kind of letting it represent what's actually real
Yeah.
and then traversing it, right?
I
Which is if
love
you,
that about it.
if you try to force something into a relational model, you're really torturing the concepts and even the data to fit this box, right?
Yeah.
And that's not reflective of the real world. And so you'll have trouble. I mean, it's just like, I mean, I could talk randomly about all kind of stuff, but like I'm going through QuickBooks now and like trying to run some reports and like, Jesus Christ, it's hard. Like, why would this be so hard? And it's because they took this multifaceted thing and forced it into a little box. And so
Yeah.
you gotta move all around and look at it different ways and run different reports to get basic stuff. And it's like, why is this the way it is?
Yeah,
I don't know. I
that's
could,
that's so well said. I mean, in QuickBooks, at its essence, like, okay, what was the relational model um, devised to solve in terms of
right,
business problems? Business process automation. Well, okay, what's the IT problem underneath that? It's digitizing paper forms,
right.
and and those are relatively fixed, and they don't change very much. And then joins were, kind of invented to rehydrate forms that, the normalization rules require to be torn apart. And and the
That's funny. That's a
and the
that's brilliant.
yeah, it's I've been thinking about this for a long time, and it's yeah, the having, worked in relational for still longer than I have in graph actually. But
Wow.
but
Let's do
the
that. Let's
yeah,
do
I'd be happy to. Yeah.
so what I'm just trying to think of how we pitch this. Let's make it all about graph.
Yeah.
Um or about database because we're going to the snow. I don't imagine you're going to Snowflake.
Oh, so we don't have a booth, but we have a couple people there, and we actually have an announcement, and I'll tell you about it. And
Okay.
obviously, you know,
Then we
and
can if since you have an announcement, we can kind of work this all into a Snowflake story. That's
yeah,
good because that way I'm interviewing someone else about the Snowflake Summit in like an hour.
okay,
So this allows me to thread that together. But I think what you're talking about here with the standard, but also with graph and helping people understand graph is hugely valuable, right? Because I think most business people are just kind of scratching the surface of understanding, all right, well, what is this graph again? And is it this like an access database or what is this stupid thing?
right,
Like
right,
they
yeah,
just don't know. And I think you're very articulate on that. So I'll start. How much time do you have? Like 20 more, 30 minutes or something?
yeah, sure, sure.
Okay. All right. Let
And
me go ahead.
would you? can I show you a demo before we start, and we can decide whether to include this or not? This is a super quick one. Oops.
Yeah, I'll do that. Hold on. I have to allow you to.
While you're setting up.
Sure. Okay. Yeah,
Uh,
go ahead and do that.
okay, one sec. Um, okay.
So as we were saying, all the
Oops. All right. I don't want the audio for that. That because your question of I have all this data, like how on earth do I get it into a graph? That just seems so hard and
Right.
complicated.
Right.
And so something we launched um, just um, is kind of like beta learning, not something you'd want to put into production, but
Mm-hmm.
something to just get people to see that it's not actually that hard. And so here you have unstructured data, which in the LLM era is what a lot of people are focused on right now. So you can choose a Wikipedia source, YouTube video, PDF, um, map that into the graph. I'm going to fast forward and not go through the whole thing. Um, and then basically click a button. And here what it's done is it's done some entity extraction with your LLM of choice, loaded that into the graph. It's also chunked everything, and then it's created a lexical graph, so a graph of the chunk. So chunk, next chunk, next chunk. Chunk is on table one, is on page 36, is in this document, is in this collection. And then maybe you can add authors, so on, but which, there's not the data for that here. And so at the click of a button, you could just take a YouTube video that came out, say yesterday, and then do rag on it. So load it into the graph, entity extraction, and then do rag on it with meaning vector and graph rag. So let me fast forward to that part. So here you can see some questions being asked of the data set.
This is
With it.
crazy.
Isn't this amazing?
So, like, help me understand the process of where because I understand, RAG is basically a workflow around an LLM, and it can take any number of forms. And what you want to do is, have your vector database, you load your embeddings. Those are like your anchors of truth, basically, as I've heard them described, which is very useful. So I give a prompt. You can have it go through your vector database first, like to say, okay, this is the information I want you to focus on. Then it goes to the LLM to spin up some text, and you can have it come back through on the other side to say, okay, does this match what they asked me for? It does. Okay, go ahead and deliver the response. Is that a fair assessment of how that works?
It is. So it's here, let me show you another thing, and then we can get to recording. I realize I'm
That's all right.
just
Oh, this is good.
distracting us, but um okay, so let me see. This is the talk I gave yesterday where I went through exactly that. Okay, it's deciding to be frozen now. Um, all right, so you vector-based RAG is exactly what you said. So you have a question, there's some parsing, chunking, vectorization that happens. You match against, some chunks in a vector database, send that to the LLM, come up with an answer, and that answer has, the vector database can be kept up to date more easily in the model. So you have a currency benefit, and then you have more specificity around your enterprise data.
Mm-hmm.
But what is a vector ultimately? It's and obviously there are different kinds of vectors. So here we're talking about a word embedding, and which is a big number and dimensional space that describes
Mm-hmm.
that describes a concept based on a statistical analysis of word frequency and proximity. And then you can do these kinds of queries and say, okay, I'm gonna bring back my fruit, and it'll bring things back, and then but then it doesn't actually, there's no knowledge in there. So you might accidentally bring in Apple, the company, in
I
addition to
see.
Apple and Apple. So LLMs and vectors share this symbolic view of the world where everything's just numbers based on statistics about word proximity and frequency. And so you end up with, even with vectors, there's no no explicit domain understanding. It's dealing in words not meaning, non-deterministic, lacks explainability, etc. And so you still have all these concerns. And so the knowledge graph view of an apple is more like this. It's like, okay, I have declarative knowledge for whatever my domain is. Trivially here it's an apple, but it could be a, smart city or, or the design for an airplane or a payment network or, so on. And so this is all explicit. It supports human and machine reasoning, whereas the other one, humans can't make sense of. Um, Relates concepts, is deterministic. And so you add these two together and so you have vector-based RAG and then you have graph RAG, and graph RAG is actually bringing data
Oh,
from the graph to your LLM. And
I-
so
I'm
same
starting to
exact
get
pattern.
it. Yeah, I'm starting to understand. So what you're saying basically is in this traditional Apple vector purely numerical view of the world, it is just numbers reflected back as words. And so there is no understanding, there's no meaning.
Yes.
But with the graph rag, what you've done is you've embedded the semantic awareness component of the graph into the patterns reflected. So it's an organizing agent, essentially, graph rag. Is that about right?
Yeah, that's exactly right. Yeah. And it could literally be like an agent. So that's actually a good word. And so let me
Wow.
just show you one more thing. So here's the kinds of results that you get. And we have lots of customers doing this across many different domains. With vector-based RAG, this is actually from a tutorial we have that's out on GitHub. Um, with vector-based RAG, you a lot of people want to basically query a set of documents. So here we took a bunch of SEC filings, loaded them into a vector database. We actually happen to use Neo4j for that, which supports vectors, but lots of folks support vectors these days. And asked the question, just using the vector-based RAG, which asset managers are vulnerable to a lithium shortage?
Mm.
Um, and
Wow.
and so the answer is pretty reasonable, right? Coming out of vectors. It's like, well, companies that produce batteries, okay, let's say the batteries have some source material and that's vulnerable to climate change. This all just comes out of words. So that's actually pretty amazing. But then with the graph rag approach, which asset managers are vulnerable to a lithium shortage, you get a list of companies. Like
Wow.
how much more actionable is that? If I'm an asset manager trying to rebalance my portfolio based on some event, the difference between this and this could be like $1 billion, um,
Wow.
yeah,
That's interesting. And so, part of the graph rag again is that you're incorporating this organizational component that is semantically driven. So you're adding an extra layer that says, okay, now keep in mind, all I want are the apples that are actual fruit, basically. Like that's
yeah.
the
And then,
refinement of the search that then goes deeper, right? Because
yeah,
it's a
yeah. And
question of you're
yeah,
stringing things together. It's always a workflow of some kind, right? And you're stringing together the steps to get there. And with the graph rag, you've treated semantics as a first class citizen, and thus it can serve as the organizing agent for your responses and what you get back. And that's like hugely important, right?
yeah, yeah. And you can even like in things that are mostly word oriented, turns out you can use the graph to rank your vector results as well.
Mm.
Of
Oh,
okay, what are the most important documents or chunks? Well, maybe the ones that have the most inbound links from customer service tickets or whatever it might be, into some solution, knowledge
wow.
base. And so, yeah, so yeah, this is a whole new world.
That is cool. All right, man.
All right, let's do it.
Let's hit the record button. This is fast. I love Graph. I'm so glad I hooked back up with you again because
Mm.
I love the way you can conceptualize and then analyze. Now, there have been hindrances over the years, but all right. So let me think about let's talk about the oh dear God. Dog going
You're
bonkers.
saying like GQual, standard, Snowflake, knowledge graphs, graph rag,
Right.
however you want to do it is
Yeah.
lots of opportunity.
I hear my dog just barking like crazy at the mailman out there. God damn. That dog makes me nuts. I
I
love
mean,
him.
but your all of your hardware and software is totally canceling that out, so it's not
Okay, good.
bugging me. Yeah.
All right, here we go. Stand by. I'm going to start my stopwatch here. So it'll go about 17 minutes.
Okay.
And then if we have time, we could do another one. All right, ladies and gentlemen, hello and welcome back once again to the longest running show in the world about data. It's called DMRadio. Yours truly, Eric Kavanaugh, here with an old friend of mine, folks, someone I interviewed, I think almost 20 years ago. Time flies when you're having fun. He's now the CTO for Neo4j, one of the most prominent graph database vendors in the world. And of course, we're all gearing up for the big Snowflake Summit in San Francisco. And Snowflake, as I say, is a center of gravity these days, at least in the relational database world. They're doing a lot of interesting things, lots and lots of partners. But Neo4j has been doing graph database for longer than most, I'll say that. And graphs are such fascinating constructs. Of course, you may recall graphs persist data in nodes and edges. Typically, a node is an entity, and edge is some characteristic of the entity. But we're going to talk about that, a new standard that has just been adopted, like SQL, which of course has been the standard query language for databases for a very long time, and also some interesting things around property graph and graph rag. So retrieval augmented generation, how graph can be very useful in that world as well. So with that, welcome to the show. Here we are, Philip Rathle, and formerly of Embarcadero way back when. Now you're the CTO of Neo4j. Welcome to DMRadio. Tell us a bit about what you folks are working on. Maybe let's start with just give us an overview of Neo4j, where you are now, and then let's get into the standard stuff. Go ahead.
Sure. So great to be with all of you, and thanks, Eric. It's been a long time. Great to reconnect. So Neo4j, graph database provider, and we've been, you could say, leading the way in graphs for the industry for a long time. So part of our vision, which we'll get into shortly on this standards side, is that the property graph model offers so much potential for everything from digital twin, graph rag. Who knew that was going to happen? But it
Right.
turns out we've accidentally built exactly the right technology over the last decade plus to ride this very important wave. But also for the kinds of real world data that you have, just that manifests between biological networks of supply chains, networks of people, networks of
Right.
computers. A lot of the data that we just interact with in the real world that
Right.
your company, your project needs to be able to master, is can certainly fit in tables. But if the data is fast moving and it's flexible, and you want to change your requirements from one day to the next, or bring in new data from one day to the next, and understand the data relative to the shape of the network. So understanding like how communication patterns reveal different communities that are not otherwise obvious, except for doing some graph querying, or multi-level supply chain
Right.
risk kind of optimization is,
Right.
all right, there's a ship in the Suez Canal that's, sideways. What does the world do?
Right.
And then, how do you de-risk your supply chain and understand all the cascading impacts? So really, we've been working on this problem of helping individuals and companies see beyond the headline, uh,
Right.
into the deeper effects, which reveal context and causality.
Yeah, that's just fascinating stuff. And you made one sort of comment there, which crystallizes in my mind the difference, right? With relational databases, rows and tables. Okay, it is technically a three-dimensional view of the world, but at its fact table level, it's a two-dimensional view of the world, and the world is very much three-dimensional. And so when you try to fit all sorts of data into a relational model, you're going to run into lots of problems. And we've talked before about how you can then flatten the data to normalize it, either to run reports on it or something, but that's a pain. It's difficult to do. And the nice thing about graph, especially what they call flexible schema graph, is that you're open-ended about how you look at the world. You can load a whole bunch of customer data. The customers are nodes, their purchases, their purchasing history, maybe those are edges, but then the objects they've purchased are nodes as well. And suddenly you can start looking at the situation and understanding the shape of how your business runs in a much more intuitive way than you could trying to look at rows and tables, right?
Yeah, something I appreciate, especially with having been in the data modeling tooling space for many years, is that there's a huge distance between a conceptual, logical, and then ultimately the physical model. And so
Mhm.
any new project, and I lived through this many times, you start doing some whiteboarding with your technical and business experts. And then, 3 months later, you end with this carefully normalized, denormalized, nth normal form kind of physical model, and that actually creates the basis for some real communication challenges of how does my developer who has the domain view, maybe in some object model, communicate what they're trying to do with the DBA, and likewise, how does IT communicate with the business? And so having a model that where your conceptual, logical, physical model are very, very close, if not identical, and where also the way the data shows up in the real world and we conceptualize it as humans, lands into the database in exactly that way, in a way, to your point, where if I have new kinds of data that I want to bring in, you just add it. No refactoring, no, finding a 1 hour window, per quarter where
Right.
you can carefully migrate your schema.
Right. Yeah, I mean, this is fascinating. And so let's get into use cases. So there are lots of reasons people can use a graph database. I find it extremely valuable in the discovery side of the data world, because understanding what's happening and wrapping your head around the possibilities, the implications, you kind of hinted at being able to understand impact analysis, for example. If this ship turns sideways in the Suez Canal, well, how do you figure out the impact on that across your suppliers, across the companies that you serve, for your own supply chain reasons? I mean, Graph allows you this really broad flexibility to be able to track dependencies and then run assessments and figure out what to do, as opposed to, again, document databases, relational databases. I mean, they have a lot of great use cases, but that use case is not really aligned with their models. What do you think?
Yeah, agreed. And much like in the relational world, you have your kind of OLTP, operational transactional world, where that usually brings in high availability, lots of transactions. And then you have your analytic world. And obviously, everyone wants those two worlds to be able to come together and be, available under one roof. Um, in the graph world, you also have these two sorts of worlds, which where there's a virtuous cycle between the two. So being able to explore, so you have exploration benefits and then development time benefits, as to be able to actually see and understand your data in a way that your brain thinks about it.
Hmm.
Um, and then there's the runtime benefits in production that generally have to do with being able to do multi-level queries, and many steps removed supply chain kind of operations, or a number of car and airplane manufacturers have their entire product hierarchy inside of Neo4j. And so it's a million parts in an airplane, and it's parts of parts of parts and parts. And that ends up being a digital twin of each individual plane that follows it throughout its life as things get changed in and changed out. And you need to do dependency analysis and calculations. And then, we have some auto manufacturers who are actually taking that. There's a great video on YouTube that Volvo did describing this of, okay, I have all my parts of the car, but then who in the organization is the point person for each part, and then what functions do each of the components serve, so that if
Right.
I'm, want to do some work on one part of the car, then I can bring all the right people to the table. And, this is accessed by everyone in their organization effectively. So coming back, there's operational graph use cases where, you're doing things in real time, like recommendations, fraud detection, or frankly, just having a real world, some kind of real or digital world, digital twin that needs to be queried by an application. And then you've got this analytic exploratory model of, all right, something just happened in the world. I need to go and explore and analyze and visualize my way around it. So you can do that as well.
Hmm. Yeah, there are many use cases. Let's talk about the standard. So in the database world, people understand ANSI SQL standardization. I think 1992 is the established one. Of course, it's 2024 now, but at least there's a standard that people can adhere to. And so any company that wants to build a new technology, as long as they adhere to the standard, they know that most people who know SQL are going to be able to use that. And hitherto, that was not really the case in the graph world, but now there is an ISO standard. Is that correct for graph?
Yeah, this is a big deal. I'm glad you brought that one up. For the last 37 years, since the initial publication of SQL, and so SQL 92 is the one most people have heard about because it was this very robust version of SQL. The initial launch of SQL was in 1987 under ISO, which then ANSI sort of inherits the ISO standard. And every new model that showed up in the intervening 37 years between then and now has basically been absorbed into SQL. It happened with objects, happened with XML, happened with JSON, and so on. And what the ISO committee deemed significant about property graphs is that it's such a different model. It's isomorphic with relational. Anything you can put in a relational database, you can put in a graph. But the uses are, and it's a model that has such significance that there was a new standard approved in 2019 that actually was published 5 years later, just last month. So pretty big deal that you now have two sibling languages, SQL and GQL, one for
Hmm.
the relational model, one for the relationship model, so property graphs.
Interesting.
And yeah.
Yeah, GQL, and I like that it's very simple because there was also Sparkle. I remember Sparkle is a query language, and you made a very good point that in this space, it is best to have all the competitors just agree on a standard such that it's usable by a much broader audience, right? Because usability is so important in the world, and we're seeing as a general rule now, look at open source, for example. There is this very strong movement these days in the open source community. And guess what you get from that? Standards. You get a de facto standard when you have so much emphasis on open source, and it reflects user demands, really. Users don't want to be locked into proprietary standards. It's just a very difficult thing to deal with. People don't like it. And now you even see, what was it, Google? And I think one of the other big ones has killed their egress fees for cloud hosting, which was the other big lock-in. So point is, people don't like lock-in. And so there was an effort made to standardize across all the different graph vendors on GQL, and that has now been formally adopted, right? Last month, I guess you said?
Formally adopted last month. Vendors are, including us, are now working on it. The good news is we've also spent the last 5 years evolving Cypher, which is become the de facto language for graph querying, and most graph vendors already support that. And so the evolution from Cypher to GQL becomes kind of merging tracks, kind of gently and slowly rather than having to jump from one track to another, which was also important to us. So
Right.
but it's so important to not, have a single agreed upon high quality language that the whole industry can use, that then as a practitioner, you can get much more value from your skills than if it just worked with an individual technology or a set. If you're um, if you're a CIO making portfolio decisions, you don't want lock-in, to your point. We want our customers to, we want to earn our customers' business, and feel everyone should be on that same page. And then that actually provides some level of confidence in deploying more broadly, knowing that this is an international
Right.
standard.
Right.
I think also inside of academia, there are graph curricula that have existed in universities, but now that there's an ISO standard, that's going to start to show up more broadly, which will feed the pool of skills, which will
Right.
help evolve things.
Right. Well, which is like and it's interesting because I've watched these patterns develop over time, but there's tremendous awareness now about the importance of fostering a productive developer community. You want developers to learn how to focus on your space. In this case, it's graph. And so the more activity you get, the more of a community you build around a standard like GQL, the better it's going to be for everyone in the industry, and the more you can rely upon it. I mean, I'm old enough to remember when NoSQL took off and everybody was so excited about this like 15, 12 years ago, I guess. And then about 2 years later, what did you see? SQL on like bolted on top, right? SQL on Hadoop and SQL here and SQL there. So it's like they tried to move away from that standard and they paid a price for it, and then they had to come back in and bolt SQL on top of these new engines, right?
No sequel turned into yes sequel pretty quick, didn't it?
That's pretty
Yeah.
funny.
Yeah.
Well, again,
Yeah.
it's important because of developers knowing what to do with these technologies because of standard. It's like, and you made a really good point about communication inside the organization. I mean, these are to many people a hidden cost because you don't realize the hindrance that you are injecting into your corporate culture when you have these communication issues between different teams. And so with Graph, I thought it was very interesting. The physical, the logical, and the conceptual model are all very similar. And so you don't wind up having this confusion or this tension between teams as much when you're trying to change things to reflect your business, because that's really what you're doing. And we've got a break coming up here in just a minute, but I'll try to tie this off. You made such an excellent point about the importance of having fluid communication within the organization, because when you look at the world, and the world is changing, and it's changing very quickly these days, and that means you want your business to be able to change as well. Well, at a certain point, that means how you use your data is going to change. That profile of usage will change. And you're already seeing this with self-service BI, for example, with self-service data management. That's a very different world from the I'll wait to get my reports on Monday from the BI team. I mean, that's just a whole different ball game now. So we're getting more agile in terms of absorbing information. We need to be more agile in terms of responding to all the information that we absorb. And that's what we'll talk about in the next segment here. But very interesting conversation. Don't touch that dial, folks. We'll be right back. You're listening to DM Radio.
Completely agree with all of that, Eric. You could say that the real world problems that are new problems that are being faced today with real world data that's fast moving, today's business velocity and today's, you could say everything that calls for a digital twin of your payment network and your biology and everything that's going on in the world, supply chains, that this is a model that's designed for that. And it works really well alongside the existing model. And the fact that they both came out of the same standards organization, SQL and GQL, literally the same committee, gives you great confidence, interoperability. It's a good basis. What I'll also add is James Governor from Redmonk pointed out that what GQL does in the Gen AI stack is it provides a clear standard for that part of the stack in a world where actually much of the Gen AI stack is very much still in the formative stages, and if not Wild
Right.
West.
Yeah, I know that's an excellent point that you just made, right? So now, like, you need some stability somewhere in order to understand and be able to plan. And right now in this LLM space, and I'll just throw some thoughts at you.
Yeah.
If you look at where we've come from mainframe to client server, well, that was a transformation. Companies had to refactor their software or rethink how to design software in the client server era as opposed to the mainframe. Then the cloud comes along. Early days, you had ASPs, application service providers. Now we have SaaS, software as a service, but still that required a fundamental change in how we design. Then Kubernetes comes out and containerization, first Docker, then Kubernetes, and that caused a massive refactoring of how you actually design, deploy, and manage your software. I would say that what we are now seeing is another major refactoring as companies try to figure out how they're going to fit into this new AI infused world. And really, it's all about where you fit in the RAG model, I think, because you're going to have these LLMs and foundational models, which do amazing things. We're just scratching the surface on what they can do. But there are drawbacks, there are flaws. I mean, I joked that my buddy Usama Fayyad, who was the first chief data officer for Yahoo years ago, he jokes, these new models, they're too big. They're not supposed to work. We don't know why they work. You're like, what? This is the guy who should know almost everything about them. But my point is that I think, again, software companies are going to have to reimagine themselves in this new world, which I think is the new de facto standard. And GraphRag plays a very interesting role in all that. So just quickly, what do you think about my theory that we have to change again? And then talk about GraphRag and how it bakes in this semantic awareness as a first-class citizen. Go ahead.
Yeah, I mean, platform shifts cause a lot of disruption and opportunity, and what that means for the tech stack. And I'd add mobile actually to the, to your
Oh,
list is that each time we have this new technology emerge, then okay, you've got a whole bunch of new supporting technologies and infrastructures that need to come along for the ride, and that gives you, there's a necessity, but it's really all about opportunity. Are you going to be early and do it well, in which case you gain a competitive advantage, or are you defending against competitors who've already done it and then you're more in
right.
mode? And and the same company can be doing both at the same time, right? Like in different parts of their business. But ideally, we will all want to be ahead. I mean, and it's been great to see the number of companies that have just jumped on board and practitioners, trying to figure all this out. I live in Silicon Valley, and in San Francisco, there are at least half a dozen, sometimes a dozen, Gen AI gatherings per day. On
Wow.
weekends, on weekends, it's maybe down to 4 or 5, but still 4 or 5 on a weekend day. Um, and so we're all trying to figure this out as we go, and every day, every week, there's a new discovery. But one of the things that's been pretty clear is do you remember when Google launched their knowledge graph in 2012? There was this blog post called Things, Not Strings.
No.
So the idea was, all right, so why was Google even the dominant player in 2012? Let's rewind a bit, since you brought up Yahoo. So
Right.
in the mid 90s, web search was entirely based on just text-based search, text matching. So that was pretty impressive as an engineering feat, is to index the entire World Wide Web and then provide a front end to potentially unlimited number of users, the whole planet. And then after about 10 years, you ended up with just so much noise that you needed a way to filter that down. And so Google launched, and they were not only the biggest search engine at the time, but they had PageRank. And PageRank turns out to be a graph algorithm that lets you prioritize and rank your pages, so your top 10 blue links, based on how many inbound links there are. And then this is iterative. How many inbound links do those have? Let's weight those according to that. So Google became dominant because of that one invention, one graph algorithm.
Wow.
And then a decade later, what happened is, this is all in the domain of words and strings, with a little bit of graph augmentation, is, you search for Rio, and do I mean Rio the movie? Do I mean Rio the city? Do I mean Rio the hotel? Do I, mean something else? And so they started to inject meaning into the queries. So you ended up with a Google Knowledge Graph, and this is where you search for a movie, and you get this panel to the side. It's called a Knowledge Graph panel, and
Right.
then you can actually navigate the graph. So we're in an era now where people are at the leading edge are figuring out that LLMs deal purely with words, vectors deal purely with words. Now it turns out you can do an impressive you can get impressively close to human meaning just by playing statistical games with words through LLMs and vectors. But this is your observation that your friend's Yahoo's observation of, man, we don't know how these things work, but they're pretty good. But on the other hand, like hallucination, these things are going to continue hallucinating, not having specific enterprise knowledge, not being able to relate things, or come up with exact answers or be explainable. They're all a black box. And so
Right.
knowledge graphs end up being a perfect complement to vectors. And you hear the term graph rag coming up, which is doing vector-based search, doing retrieval augmented generation with not only data from a word vector embedding, but also bringing in data from the knowledge graph.
See, and I think this is the key. And so my theory here is that, I mean, first of all, these foundational models are so powerful, they are going to subsume most of traditional enterprise technology sooner or later. This is my theory. Maybe not. It's hard to say. I mean, I've never actually been more unsure about what's coming,
Yeah.
at least specifically, because it's just hard, right? Because these things are very, very powerful, but they are centers of gravity, and they're just going to attract engine and I mean activity and interest and financing, et cetera. So they're big and they're changing things. So the key is going to be what is the workflow around this engine, and that's what RAG was from the first place in originally, right? Is retrieval augmented generation over at Facebook or Meta, I guess they call it now. They realize, all right, this thing it just goes off and does crazy things unless we have to kind of hold it down. So these are your constraints or anchors of truth, is what someone referred to them in terms of the embeddings. But you can get very clever about the RAG model. And what I love about this graph RAG thing is that basically in the model, as you do your prompt, it's going to go and check for this semantic layer first and align semantically, and then grab some information, grab the text generative capacity of the LLM, and then you could even do some fact checking and some governance on the way back before it gives you the answer. So it's like you got little fact checkers, and I mean, that's kind of what these transformers do anyway, right? Is that you have this additional layer of decisioning on top of the initial layer, which is now you have like five little bots saying, I think it should be X, I think it should be Y, I think it should be Z. And the guy on top says, I'm going to go with Y on this one. So you're building in layers of reconciliation, really, and using the semantic organizational capacity of graph to really align and true that wheel. What do you think about that?
Yeah, I agree. And one way to look at it is if you look at the brain, you have your left and right hemispheres, and they each play a different role. And if you have just one, then okay, so right brain we usually think of as being spontaneous, creative, um, not really explainable. It usually makes great decisions. Sometimes they're spectacularly bad, and I have no idea why I did what I did, but I did it.
Right, right, right,
Um,
right.
and
That's funny.
and this is how LLMs behave. Like we've all experienced this. Anyone who's played with ChatGPT, even 4.0, knows this. And why is that? It's because it's based on this. It is inherently this black box model that is built on a word model. And so, we kind of think it's a world model, but it's a word model that, kind of approximates that. But so what does the left brain look like? It's concrete, it's rational, it's deterministic. You'll reason through the same decision every time and get to the same conclusions. Um, and so so graphs become then the left side of the brain. And for Gen AI, we actually want both. You want, your creativity and your spontaneity and, being able to draw from all this knowledge and have mastery over words.
Right.
But then you also want to be able to get visibility control over, these guardrails are kind of loading the dice as you were describing with vector embeddings, where you narrow your margin of error. With GraphRag, you can either narrow it further if you're delegating the reasoning to the LLM, or if you're doing the reasoning in the graph for things where you need an exact answer, how tight am I going to tighten the bolts on an airplane? Like there's no room for even
Right.
0.01% error.
Right.
Then you do the query in the left side of the brain, and then the LLM helps to reformulate the answers and bring it into language.
That's really fascinating, and I'm going back to an epiphany I had. This is in fact before the Gen AI stuff even came out and became popular. But I was asked to give a talk on AI versus data warehousing, and what I basically said is it's not going to be AI versus data warehousing. It's going to be data warehousing and AI, and they are different things. And the concept I came up with, I'd love to get your thoughts on this, is that when you have both, you can get depth perception because basically the data warehousing is going to be this deterministic component. The AI is going to be more stochastic in nature and discovery oriented, which is very important to think outside the box, so to speak. Like literally, the data warehouse is a box, and AI is thinking outside the box. But what I said is one is like your left eye, one is your right eye. If you have only one eye, you don't have depth perception. You need the triangulation of two eyes to be able to see where something is close to you. So that my argument back then was what you want to do is find a way to strategically fuse these two views of the world in some meaningful way. That's going to be inside a RAG model right now, whether it's at the end or at the beginning. The point is there's going to be a workflow around this stuff, but you want to keep your deterministic view of the world, the data warehouse, but you also really want to have this other view of the world. And to your point, graph is a huge part of bringing all this stuff together. But what do you think about that whole analogy and where I'm going with that?
Yeah, and it's funny. I see that analogy with data warehousing and Gen AI. I think that's right. I also see that analogy with kind of the left brain, right brain of your knowledge graph is your source of truth for, data in the real world, like we were talking about earlier, of, I have a digital twin of some complex system. The data warehouse will be your source of truth for, maybe sales orders and, all the various transactions that occur in your business. But then
Right.
you also need a source of truth of how things are connected. Now, it's something we're actually announcing at the Snowflake Summit. Can I talk about that?
Yeah, go ahead, real
Or
quick. Go
yeah,
ahead. Yeah, tell us.
yeah, great. Is actually being able to bring the data warehousing world closer into the graph world. So you'll actually be able to, um, and this is something that's actively being worked on, should GA in a few months, of um, being able to run inside of your Snowpark container service, um, rip data out of the tables that you want in Snowflake, run some graph computation on it, and then push it back in, and then it's a serverless ephemeral graph service.
Wow. That's the announcement you make. That is very, very, very cool. And what is that called? Is there a name for that?
It's graph data, Neo4j graph data science.
Neo4j Graph Data Science. This is absolutely fascinating stuff. We have to get you back on the show sometime. Folks, we'll be talking to Philip Rathle, CTO of Neo4j, one of the longest standing graph vendors out there. Very, very cool stuff. Look these gentlemen up online. You are listening right now to DM Radio.